Okay, I think it's time. I'm going to start. Thanks for coming. I'm going to be talking about this tool that we're using called STF. A little bit about me before I go on. For those of you who don't know me, my name is Daisuke Maki. I go by the handle Lestrat. I came from Tokyo, Japan, and I'm jet lagged to death right now. I work at this company called NH in Japan. If you know anything about Japanese internet companies, this company used to be LiveDoor. We got bought out recently. And I run YAPC Asia Tokyo, which I'll be talking about in my lightning talks later. Okay, so what is STF? STF is basically what you call an object store. The only purpose is to store and serve files, which are called as objects. But it's a scalable object store. It has to store and serve billions and billions of files at the same time. Okay. It's like an S3, except I used S3 for a while. Maybe it's not the case anymore, but I just couldn't figure out what the hell was going on when something went wrong. I really hated it. And it currently powers a lot of our services. It runs behind our blog services, our Flickr clone, other specialized blogs for different targeted customers, news sites, and Foursquare-ish location services, and also there's a matchup service that stores a lot of stuff in STF. And basically, it stores user-uploaded media, right? We have about anywhere from 400 to 500 million objects in there, which I'm going to explain later, but it translates to about 1.4 to 1.5 billion actual physical files. And this is all done in less than 100 servers, just your regular Linux. I think we're using CentOS. And this is at about 40% capacity, so we're doing fine. So when we built STF, we had a few requirements. So first of all, it has to be able to handle a lot of writes, file uploads. And it has to handle massive, massive amounts of reads. And hint, photos. So yeah, we needed to be able to scale relatively easily, and we had to scale to handle all this mass reads. And again, this is the user-uploaded media we're talking about, so we don't know how many photos they're going to be putting up, or what the size of each files are. It could be really small. Maybe you could have thousands of small files. Maybe you could have a few, megabyte-sized files, whatever. Anyway, so the actual physical storage could grow large. So you have to be able to kind of just stick another storage in and have it scale. Another requirement, yeah, it powers that whole slew of services, so you can't have a downtime. It's got to be able to write all the time. It's got to be able to read all the time. And, of course, you can't lose data. What else? Oh, yeah, and we got to do all this was relatively easy. I mean, we didn't want to have to, learn new set of tools or new OSs or whatever, appliances, whatnot. We're lazy. We want to do the minimum possible to serve all these files. And, use a tried and true technology. Okay, so we built it. And the basic idea is that we're just going to do everything with HTTP. HTTP does fetching. You can put stuff, so it works. And I guess you'd be asking this question, why not just use an existing solution? And obviously, as I already mentioned, S3 is almost exactly how we envision it to be. The reason we're not using S3 is because, first of all, we own a data center service. We have servers to sell. We don't need to rent it anywhere. Second of all, because of that, we have really good infrastructure guys, and sure, you can go grab a new instance of a server using S3 or whatever cloud services with a click of a button, but it's just as easy to ask these guys to boot up a new virtual server, and you get a new one immediately. So, and as I said, as far as S3 goes, I really hated it when I couldn't figure out what the hell was going on when something didn't work. So we wanted things in our hands. Also, S3 costs a lot for us. We did some very rough calculations. One instance that we use, the biggest instance is our blog services. It generates about 330 megabps. That's not daily average. That's a average over a day, but it's per second. So any second you could just go could be serving all this data. We are storing over 30 terabytes of original data, and that's just the originals. We have to have copies in order to make sure we don't lose data. So we actually have twice or 3 times this amount. And that pretty much adds up to like $15,000 a month or more. This is a very rough estimate, and it could be more, but anyway, it was enough for us because we had all servers. We couldn't convince ourselves to spend all this money for stuff that we already had, so we just built it. The other option was Mojave FS. Anybody use this in production? 1, 2, 3. Okay. To be honest, we could have just used it. The only real big drawback that all of us in the group had was that we hated the protocol. We just didn't get why the hell it was doing it, and we didn't want to learn it. So, oh well. And from what I heard, there are some peculiar behaviors where when you put a new storage node, apparently a lot of the writes goes to the storage node instead of balancing it evenly. I don't know. So there's some stuff that were out of our hands, and we weren't going to do it. So anyway, so we built it. Okay. So that's what STF is and why we started building it. And I'm going to try to explain how STF works. So it's basically an object is just represented by one URL, right? If you want to put a file, you create a URL and issue a put request to it with a body. It'll just create it. When you want to fetch it, you just issue a get. There are other stuff you could do. You could get, put, delete, post. There's actually a move command too, but that's a little detail. So, but anyway, you can do all this stuff with your regular HTTP clients. One good thing about this simple approach is, you could put proxies in front of it and kind of just accelerate it or scale it just like you would scale your normal websites. So, no brainer. Just use yours. If you get to that point, you could just put STF behind your CDN and have all your interesting photos being delivered there. And just, basically, this is our tried and true way to scale. So it was good. STF is basically built with Perl. We don't use any sort of web frameworks, pretty much just raw plaque. We do require a front-end proxy regardless of all this acceleration and stuff. It's either Nginx or Apache with a mod proxy module. I'm going to get to that later. The data, the metadata, is stored in MySQL. We use 5.1 just because we want to use this thing called Q4M. Do you know what Q4M is? Anybody? We'll go there. Q4M is it's one of the pluggable storage engines for MySQL. It implements a message queue in terms of SQL commands. And it's extremely fast. It's persistent, unlike Redis. So you won't lose data. And yeah, I mean, again, we can reuse the tried and true knowledge of SQL to run this. So, and the way to control to operate MySQL server. So this was good. And we use Memcached heavily to store a lot of metadata. All right. And before I confuse you guys, I'm going to have to give you a little bit of history. STF actually existed before I started working on this. And back then, it used to be an Apache module. It used to be written in C. It had Perl workers in the back end, but it was a C project. And it also used ActiveMQ as its messaging layer. Now, okay, so as you can guess, I'm a Perl guy. I work at this company, and people and developers in this company are all Perl guys. So nobody wanted to maintain an Apache module. Development pretty much stalled for like, I guess 2 or 3 years. Our CTO wrote it and just kind of maintained it for a while, but then he got bored and whatever. And then, well, I joined. I complained and bitched that it was hard to test. I didn't want to build an Apache module for every instance of a development server that I create. And then, well, good. We wanted to port it in Perl. Why don't you do it? So it took me a while, but a few months later, I rewrote everything in terms of that Perl PSGI and stuff. It's open sourced. It's on GitHub. Right there is the URL. STF-storage/STF. I actually have on the original implementation there. I also have a half-ass Ruby implementation, and I also have a. I don't think it works there anymore, but I have a .cloud deployable version of it. Anyway, take a look at it if you're interested. Okay, so I got in, I reroll all that stuff, and the stuff in GitHub now basically has all these components. So as I said, protocols HTTP, no custom protocols, just your get, put, post, delete. And behind the supporting the protocol is a thing called the dispatcher. This is the component that talks to the clients. It's basically your web server, web application server. This handles all the communication and then does the minimum required to fulfill certain conditions and gets back to the client. The actual physical data stored in the storage servers, and there are the worker machines that do the housekeeping work for the system. And it kind of looks like this. So you got your proxy, you get your request, it goes to the dispatcher talks storage or Q4Ms, and then there's the workers. So I'm going to get into the details of how each component interacts with each other. But that's pretty much it. And let's see. What did I say? Dispatcher storage is PSGI app. Oh, yeah, it's a hot deployable. So we use this thing called Server Starter. If you were in last year's YAPC, I briefly explained it in my lightning talks. Yeah, use Japan. Anyway, yeah. So it's a super daemon to run your PSGI apps. Four Plaque handlers work with it. You can basically send a SIG hop to this process. It'll kind of do this generation switch thing safely. if you have some sort of typo in your new generation code and it doesn't compile, your protocol doesn't work, right? Then it won't switch to the new one, so your application keeps running. So we can just kind of deploy it and just try it before without much thinking. Okay, Linux servers, deploy workers, I already said. All right, so how an object is stored. So objects need redundancy. We can't lose data, right? One copy of an object isn't enough. You have to have multiple.
Suggesting that some of those babies are disposable?
Okay, I'm not going to say anything about that. All right, basically you have an object, and an object can have a physical representation of it in a storage. One storage can have one representation of the object per storage, right? So you won't have the same representation in one in the same storage. Each of these representations are called entities. And we keep a minimum of 3 entities per object. So if one goes poop, you still have 2, right? And you have time to recover and whatnot. In the current implementation, you can have more than 3 entities. The client can specify how many entities you want, so you could ask for it to store 5 entities if you want, but well, it's your judgment call. Writes happen in 2 phases. The first phase, the client needs to get either success or fail, so the dispatcher directly stores the files into the storage. In this phase, it only stores 2 copies, so that it basically does a double write, right? So if in case one of the storage goes down, you still have a copy. And if the double write works, then the client gets an OK. If the double write fails, then the client gets a uh-oh, there's something wrong. Now, after that, right, the client gets a response pretty fast because we're doing only a minimum write. And then through the Q4M mechanism, the workers get requests to fill the rest, basically. So if the client asks for a total of 5 entities, then the workers would create asynchronously 3 more entities to fill it. So then in a matter of a few minutes, you get 5 copies of your original object. And so once writes happen, then reads. Each of these files are, for what I know, they're about 10K to 10 megabyte size files. That English looks weird. What I want to say was we could just, act like a regular web server and just deliver the actual files via Plaque, PSGI, and do all the stuff. But then we'd be putting these 10 megabyte size files through Perl in memory. Why would we want to do that? Perl isn't made for that. So what we do instead is we first find which storage has the entity that we want. The proxy sends the proxy gets the GET request. It goes to the web dispatcher. Then the dispatcher does a lookup of where the entities are, right? And it does so with a head request, no content required. It just looks for where it is. And then the storages, they basically reply with, the dispatcher replies with a reproxy request, response. You know anybody who don't know what the reproxies are? Do not know, okay. So think of your regular, very basic proxy acceleration, right? The proxy gets a request. Your web app gets that request proxied, right? Your web app loads, so suppose you're just using loading static files, right? Loads that file content in the web app, right? And returns a 200 OK response with the content, right? with a reproxy, there's no content. You just return a 200 OK and extra header that says X reproxy URL. So what happens is that then the proxy goes to that specified URL, which is the storage directly. So now the content will be served from the storage, not the web app, right? So we won't be using 10 megabytes in our Perl applications. It'll just be handled by your efficient C-based web servers. So all is happy. Yeah. In case of Nginx, it works out of the box. You have to do some configuration, but it's really easy. So I love Nginx, but in case of Apache, you need this half-ass Apache module that I'm maintaining right now. Yeah, it's basically just re-implementing this reproxy deal. I actually forked it off of a friend of mine, and the original one didn't work with head requests, so I had to add some more stuff. But anyway, if you are interested in this tool, I'd suggest using Nginx because it's just much easier. All right. So that was writes and reads. Before I go on, any questions with the yeah?
Didn't you get into this to not have to maintain a Perl for Apache module?
Right. So that's why I'm not using the Apache module anymore. Right. Nginx turned out to be so much easier. And actually, I have to thank .cloud for letting me see that it's actually doable in Nginx easier. Because .cloud has a Nginx proxy in front of it. And in order to do anything like this, you have to know how to use Nginx, how Nginx works. So after I started tinkering with .cloud, I immediately just changed all our instances to use Nginx that I could. There are some still lurking out there, but I don't do daily maintenance on it, so that's okay. And if they crash, we're just going to switch to Nginx. Any questions so far? No? Okay. All right. So that was your regular read writes, right? That's how we keep the our data. But as all of you know, storage servers they crash. In fact, they crash so often. Yeah, we're using commodity hardware. We are careful as to which hard drives we use. We do check which lots they are, so that we don't have random hard drives, slipping in there and crashing all the time. However, even then, we still have crashes. So when crashes happen, so we have multiple storages, so we just issue multiple head requests until we get a healthy one. So that's why we have, 3 or more storages. So it'll just work. Now, yeah.
Something in that case where you get your X case, does that also trigger something else to say we're now low on?
Actually, yes. When this happens, let's see, what happens? Relevant caches are first invalidated, and then a repair request goes to the queue. It tries to rebuild it. So, for example, in this particular picture, there's only 2 storages, but you got to have more, right? So if there are storages that don't have the entity, then you could just get a new copy there, right? So the repair request would actually fill it and work. But still, you got a broken storage, so you're just kind of, I don't know, you're not completely safe. You just kind of fix that particular instance. So,
But not every store is supposed to have an entity. Say you have 5 stores in the one store.
well, in this case, though, you're missing one, right?
Right.
So it will create the missing one.
Okay.
Of course, if it can, right? Yeah.
Is this happen frequently enough? Do you do those requests in parallel, 2 or 3 heads at once, or do you just do those?
No, usually the first one wins because most of the time there isn't any crash storage. So
If you did something, the fastest one to reply is the one I'll use.
Well, I actually tinkered with the idea of finding the fastest one, but after a few benchmarks, what turned out was, well, first of all, when you have multiple targets, right, and you want to find which one's fastest and live, you basically have to write a asynchronous client, right? You have to send multiple requests at the same time and see which one comes back first, right? Now, this particular application is written in your regular, normal coding, right, in the synchronous mode. So when you start triggering asynchronous code within asynchronous code within the synchronous code, right, you actually get the penalty of having to start up an event loop in the middle, right, which turns out to be slower. So, no, we just do a sequential lookup. However, we do use we don't use LWP. We use a thing called furl, and we use the very basic layer of furl so that you do just enough network sending over stuff over network, just to get the minimum information. Yep.
The storage node comes back, and you field in the meantime.
Mm-hmm.
Reduce the number of entities available, or does it just keep it?
Well, I mean, it's already there, so yeah. If you're still missing something, then you would try to do something smart, but it's still normal cases. If it comes back, then it's just there. But usually, I'm going to get into this later, but you have to do manual restoration of the storages, and when you do the manual restoration, it's just going to bring everything back. So you end up having like some of the objects end up having +1 entities, but it doesn't hurt, so we just let it be. Okay, so far so easy. This is your normal mode of operation. I mean, I talked about crashing, but just crashing is okay. However, when system components go down and you have to keep STF up, you gotta do a lot of stuff. So first of all, before the actual crashing, you have to be monitoring all this stuff, right? Now this is the stuff that I wanted to show. We use these two tools that are probably that you guys probably never heard of it. It's quite widespread in Japan, but no documentation in English, so I don't think you used it. But it's really cool. Cloud Forecast. It's this guy. So yeah, I mean it's just your Muni type of thing, but the setup is so easy. I'm not going to get into details, but it gives you all the stats that you want. How much disk it's using, what the CPU rate, how much CPU you're using, number of ports that you're using on your HTTP servers, blah blah blah. So this is one indicator. When something goes wrong here, there's another thing that alerts us. So we know when servers crash. And now that just tells you your well-known statuses, right? Like you always have an HTTP server, so you can watch an HTTP server. You can always DF a disk to find out what the usage is. But for per applications, there are unique stats that you want to keep track of. So to get those, we use this thing called growth forecast, which is sort of a let me see if it fits. That's a big thing, but it's got like all of our storage servers. Anyway, this shows stuff like number of entities per storage, right? And that's something that's unique to this application. So we have to calculate the number. So what we do is we calculate the number, we post to this web application, right? And it keeps track of the data and puts it in a nice graph, so we can keep track of what's going on. The top graph there is actually like a queue, the number of elements in the queue. So you can see that there's something going on. Actually, this is a recovery going on. it's doing a logical recovery. So the queue is filling up, the worker is picking up the jobs, and it goes down, it fills up, it goes down, it fills up, goes down, blah, blah, blah. Right? So as long as the queue doesn't fill up all the way, we're okay. The system is fine. So we use these tools to figure out if STF is up. Now, we monitor it. We did the demo. And then when we find something is wrong, then we have to run the recovery. It's basically a RAID recovery, but done in a per server basis. Now, here's the problem, though. When I said that objects are stored as entities in the storages, in the storage, the storage are currently chosen at random, right? So that means max availability, but it's max chaos. You don't know where entities are. So if you knew what the entities are, you could actually just copy an existing disk, right, and just recover it. However, it's random, so you can't do it. So what happens is you have to do a logical recovery. You look up the database, right, and you have to find the missing entities and repair it. A little Japanese got in, but it says repair. Yeah. And logical recovery blows. It blows. Basically, so you don't know where the original copy of the entities are, right? So when you run logical recovery, you actually put the load on the entire system, right? And so you have to throttle the recovery process. Otherwise, the regular reads, they get blocked. It takes too much time. For a storage server that contains a 3 terabyte disk, we can use up to like 2 weeks just to recover data. This is silly. But currently, it works because we have enough entities and we basically have enough time to recover. But obviously, we don't like it. We just want to rsync it if it's possible. And this is probably the single most annoying part of STF. So, I'm working to rectify it. In fact, I've rectified it. It's just not in production code, so I can't say for sure that I rectified it. My tests are passing, so it should be working. But anyway, I've written this new cluster storage stuff. It's in a different branch. So if you do look at the GitHub repository, you have to look at it's not in the master branch. You have to look elsewhere. The plan is basically just to change how the data is stored. Make it possible to copy the data. That means basically have sets of same data in chunks. So we'll cluster it. We'll cluster the storages, right? When we say cluster, cluster would contain 3 storages or more. And the whole STF system would have 1 or more clusters. When you store an object into a cluster, then you'd have to write to the entire cluster. So you'd have 3 copies, right? But within the cluster, you'd have the same copies everywhere. Return. So here's the new model. It's basically the same picture, but the storages are organized in clusters. And when you write an object, you write to only 1 cluster, and the storages within the cluster all have the same data. So, on this new model, when something bad happens, this is what's going to happen. First of all, this is the normal state. You got storage 1 to 4. I added a new thing called spare, which is basically you write to it, but you never read from it until you really have to make it readable. And the rest are readable in the readable state. So this is the regular state. The spare isn't necessary, but just putting there for to showcase. Okay. And that ABC are entities in the storage. So basically, you see that within the cluster, you have the same set of data everywhere. So, okay, so suppose storage 3 crashes, right? You put the storage 3 to down state. The whole cluster is changed to RO. So you can still read from it, because 1, 2, 4 still have the data. But you won't be writing to it. However, this time, no randomization, right? So we just, replace the disk on storage 3, bring it back up, and just do an rsync. In this case, we have a spare server, so just rsync from a spare server, which would be the least used one. And this, from our experience, if we can rsync a 3 terabyte server, it takes usually 2 days, much better than 14 days. All right, so it's just an rsync. It's still down, and everything's back. We just put it to read-write. And you should do a logical recovery anyway, but you can do it lazily, right? And it's only going to affect this particular cluster. So you could keep the cluster to read-only and run the minimum logical recovery that's required. Because you might be missing a file or two.
Question.
Yeah.
Do you also take cluster machine 4 out of the cluster for the front end so that it doesn't add any extra push to it?
No, the information about which clusters are readable are all in MySQL, and the dispatchers every dispatcher does the same thing. They're not tied to a particular cluster,
Okay.
so they're just from the dispatcher's point of view. What used to be a one storage server is now a cluster.
Okay.
And as an added bonus, when you do this clustering thing, you can balance entities nicely. So before this, when you had a crash, one server would have 200 megabytes of data, and everything else would have 2.2 terabytes. And there was no easy way to balance it. But with this, we found an easy way to balance it. So we can also do that. All right. Let's see. And all should be good. We are expecting to deploy this in the very near future. I'm actually just waiting for the servers to come in. So maybe in the next month or so, this is going to be all online. All right. So wrapping it up. STF, we just use commodity tools, commodity hardware, and just your tried and true Perl, Plaque. The code we use doesn't use any asynchronous trickery. It's just your regular web application. We use MySQL like a dumb web application developer. We don't do anything special with it. The only piece that's kind of tricky is Q4M, but once you install it, it's a no-brainer. And if you can't afford the servers in your data center or whatever, then STF is definitely an option. If you don't have that many objects to store and you don't have the servers, then maybe S3 is cheaper for you. It depends. For us, we're handling massive amounts of, again, photos. So we have to, there's no point in putting all this stuff outside. So we just do it. Your mileage may vary. Anyway, and I'm actively supporting it. So if anything goes wrong, you can just holler at me and I'll fix it. And I got a few more to do. There is an admin interface. You can change status of each nodes and put it up, down, check what entities are in a particular storage. But the interface could be brushed up a little bit more. And I really want to be able to configure everything from the web interface, because we have in our biggest instance we have 40, 50 servers that needs configuration. And I mean, it's doable, but I'd rather avoid it. Anyway, so that's about it. Any questions? Okay, go ahead.
Do you inject something? Do you have a strategy for single bit errors?
Actually, I do, but we don't really use it. The reason being, so I asked, don't you need something like this? And when I asked, I already had the code. However, our managers are like, well, if it gets that bad, then we're screwed. So we'd like to keep things faster rather than safer. So for now, anyway. And currently, that option is you can toggle it, but it's not on by default.
Becomes a real problem. You got a couple
Right.
petabytes.
We wouldn't, I mean, again, I guess it highly depends on your environment. Our environment, if we lose it, it's basically women without clothes. So, it's not like a super secret something. Yeah. So. Mm-hmm. Right. So I completely skipped over this one concept in STF, which also exists in S3 buckets. The move is for inter-bucket move. And that only exists because some of our systems use different buckets for each user of their services. And sometimes, they rename their accounts, or they what was the word? They ban the user, but they don't want to, completely delete their files. So we just rename it, basically, right? And keep it somewhere until the user repents and, puts a little more close to the photos, basically. So. If you have, STF, the question is if you can move the files as a user, but STF in itself doesn't have any sort of authentication. Authentication currently is handled in the plaque layer. So if you want to put, you use the information in a MySQL database, whatever, you have to handle it there. And so if you can go past it, then yes, you can do whatever you want. You can even delete the whole system if you want.
Seeing if you're working with social data,
Mm-hmm.
you're really going to do some kind of deduplication in the background. So if you are check something out to the back, and then
Yeah.
see what the popular ones are. And
Right. Again, that kind of stuff I want to do, but currently it's not required by our business, so we don't have the resource for it. So that's the only reason why it's not being done. Shoot. Okay.
When trying to choose which storage server to grab from, I know that someone had asked about the quickest one. Well, maybe if you have the storage servers in different cities, could you say, well, prefer this storage server over a different storage server? Maybe have a
Yeah. Again, it's just protocol, so we could definitely put it in there easily. Currently, what we just do is we select up to, what was it? I forget, but select up to n number of storages for each object, and then sort them using hash, right? And so you have consistent ordering every time, right? You don't want when you find an object, find an object, right? You don't want to be hitting a different storage every time, because, for example, if you had a failure in one of the storages, right? Maybe it would fail on this particular request, but it won't fail on the next one.
So you prefer consistency.
Right.
And so how do you do that order when you said you do the sort?
It's what was it? I think it's the object ID plus the entity ID, and we just hash it using murmur hash, and just order it. And as far as the different data center goes, well, if you got that need, I'll make it pluggable. Which what?
File system.
File system. I actually never bothered to find out because, as I said, the first generation STF was already there, right? And I just put it over it. But I believe it's just your regular X3 with no wait time. That's about it. We are using pretty fast hard drives, but that's the extent that I know.
If you're overwriting a file, does it still select a random group, or does it find the one it's currently on?
If you're overwriting a file, the operation that happens is actually delete and then a create. So yes, it just does the randomization.
So what happened to the U at the end of the name?
Oh. Well,
Actually, does it stand for something? Or?
yeah. So the original author claims that it stands for storage farm, but it doesn't. He just liked pro wrestling. You know, was it step over toe fold, whatever? That's the whatever that is. It's a move. Yeah, it's wrestling. Yeah.
And so you're saying that for you, QFRAM is mostly just work. Have you had any issues at all with that?
Actually, no, nothing. And in fact, QForm is being used in one of the busiest social game companies, not us, too. And it's serving way more requests than we are. It works. It does have certain limitations, like the max queue size, but the max queue size is like 2 to the power of 63. And each row can't be more than 512 megabytes. So it works. It works.
And you were probably less burdened by the, and it's written by this one guy.
Right, right.
Which was a burden for us getting support, but possibly less for you.
Well, you know, I would say yes, but we haven't had to ask anything really. It's amazingly tight storage engine.
Well, that's good to hear.
Yep. Anything else? Okay.
I just saw the streaming video figure. Stuff, streaming video, sharing video with ranges and so on.
Oh, this? I don't think it supports ranges. Wait. But if the server, if the HTTP server supports it, I guess it would do it automatically. Okay, so it would. Yeah, I've never tried it. Maybe some user is already abusing it, but to my knowledge, I don't know. Yeah.
Are there any other processes from the workers in the background?
There's repair. Actually, deleting happens asynchronously because you just have to get the request and you're okay. There's also workers to detect if certain services are down or not. But that's about it, I think. Yeah, I think that's about it.
Just you mentioned looking at mobile. Have you looked at like HDFS to do for this? Even sounds very Cassandra-like.
Yeah. Let's see. Cassandra was a no-no when I started doing this because some other team already had failed to use Cassandra properly. To my knowledge, I don't know exactly what was wrong, but everybody's just like, oh, it's crap, so we couldn't use it. As far as HDFS goes, I haven't really looked into it, but it doesn't. It does a little bit more than this, right? This is just serving files. Again, the only thing we want to do is serve a lot of photos. So HDFS is probably a little overkill.
And actually, probably be wasteful with those big ones.
Probably, yeah. Okay, thank you.